Ever gaze at the sky and marvel at the fluffy or ominous clouds above? Ever wonder how they form? The formation of clouds is a fascinating process driven by a combination of sublimation, condensation, and the upward convective movement of air. Imagine air as a kind of invisible elevator carrying water vapor up into cooler regions of the atmosphere where it can transform into the clouds we see. This process can be influenced by a variety of factors. Nocturnal radiation, or the cooling of the Earth's surface after sunset, can cause air near the ground to cool and condense, forming clouds. Dynamic lifting over terrain, where air rises over mountains or hills, can also contribute to cloud formation. And then there are frontal systems, where warm and cool air collide and often create a wide array of cloud types. So those vast and varied clouds we see are the result of a complex dance between air, water, and temperature. Clouds are as varied as the weather they bring. Understanding their types helps us predict that weather. At a glance, clouds may look similar, but a closer look reveals a fascinating variety. They are primarily classified into three forms: stratiform, cumuliform, and cirriform. Stratiform clouds are large, horizontally developed, and associated with stable weather conditions. Contrarily, cumuliform clouds are vertically developed, indicating convective activity that can lead to turbulent weather conditions. Then we have cirriform clouds, high-altitude beings made of ice crystals, often contributing to halo phenomena around the sun or moon. But that's not all. Clouds also come in different altitude-based categories: low, middle, and high. For instance, we have stratus and cumulus clouds at low levels, altocumulus and nimbostratus in the middle, and cirrus and cirrostratus at high altitudes. From the low stratus to the high cirrus, each cloud tells a unique story of the weather. Understanding cloud types is more than a sky-gazing hobby. It's crucial for predicting weather and ensuring safe flights. Take cumulonimbus, for example. These towering clouds can reach heights of up to 12 kilometers, and their extensive vertical development signals potentially hazardous conditions, often associated with severe weather phenomena like hail and thunderstorms. On the other hand, nimbostratus clouds, with their thick, extensive layers, often cover entire skies and are typically associated with continuous rain or snow. Then we have high-level clouds like cirrocumulus and cirrostratus. They may create optical phenomena and often indicate the approach of a weather change. The implications of these cloud types are significant for both weather forecasting and aviation. They can affect visibility, bring about precipitation, and even cause turbulence. A cloud's shape, size, and altitude can provide invaluable information for weather forecasts and flight plans. Clouds don't just bring rain or shade. They also determine the ceiling for pilots and affect visibility. The term ceiling in aviation refers to the lowest layer of clouds, reported as broken or overcast. If the sky is totally obscured, then it's the vertical visibility into the obscuration that counts. This ceiling is crucial for flight safety, as it determines the lowest altitude at which a pilot can fly under visual flight rules. Cloud cover, on the other hand, is reported in eighths or octas, from 0 octas, meaning clear skies, to 8 octas for overcast conditions. This measure gives pilots a clear idea of what to expect above. Dense cloud cover can reduce visibility drastically, making it challenging for pilots to navigate and recognize landmarks. It's not just about the view up there. It's about understanding the sky's moods and making the right decisions based on them. For pilots, understanding the cloud ceiling and visibility is not just about knowing the weather, it's a matter of safety. Rain or snow, drizzle or hail, each form of precipitation brings its own challenges for aviation. Precipitation springs from the womb of clouds. The type of cloud dictates the nature of the precipitation. For instance, the towering cumulonimbus, with its extensive vertical development, is notorious for producing heavy rain, thunderstorms, and even hail. These conditions pose significant threats to aircraft, from structural damage due to hail impact to visibility reduction from heavy rain. On the other hand, the nimbostratus, a thick, extensive cloud layer, is associated with continuous, often gentle, rain or snow. While not as violent as the cumulonimbus, the nimbostratus can still cause visibility issues, making navigation a challenge. Even the lightest drizzle, often born from low-level stratus clouds, can lead to problems. It can create slick runway conditions, potentially affecting takeoff and landing performance. From the lightest drizzle to the heaviest hail, each drop of precipitation can have significant implications for aviation. For pilots, the sky isn't just a vast expanse. It's a landscape with its own hills and valleys made of clouds. Each type of cloud presents its own unique set of flying conditions, and understanding these is crucial for navigation and safety. For instance, stratiform clouds, with their large horizontal development, often indicate stable weather conditions, while the vertically developed cumuliform clouds signal potentially turbulent conditions. The altitude of cloud bases also plays a significant role. Low-level clouds like stratus and cumulus can obstruct visibility, while high-altitude clouds like cirrus and cirrostratus can create optical phenomena that pilots need to be aware of. Moreover, pilots must constantly adjust their flight plans based on ceiling heights and visibility constraints. This is not just about flying above or below the clouds, but also about understanding what they signify and how they can affect the aircraft. Navigating the skies is a complex task that requires understanding and interpreting the cloud landscape. Visibility is a crucial factor in aviation, but what causes reductions in visibility? Various phenomena can cause this, including fog, mist, smoke, dust, and volcanic ash. Let's explore each in turn. Fog is a cloud that touches the ground, formed when the air near the surface cools to its dew point, or when moist air moves over a cold surface. This can significantly reduce visibility, making it challenging for pilots to see other aircraft, the runway, or navigation aids. Mist, similar to fog, is a collection of tiny water droplets suspended in the air. However, it's less dense and doesn't reduce visibility as much as fog does. Smoke from wildfires or industrial sources can also obscure visibility and sometimes even aircraft instruments. Dust storms, common in arid regions, can reduce visibility to near zero, presenting serious hazards to pilots. Finally, volcanic ash, a rarer but serious threat, can cause visibility issues and even damage aircraft engines. From fog to volcanic ash, understanding visibility reduction phenomena is key to maintaining safe flight operations.